All right. Happy Friday, everyone. We're going to get started. So, I had three requests for people to do problems, but there were a lot of them. So, we'll go through them one by one. If we don't get to any of yours, if we skip over it, just let me know, and I'll go back and do that one as well. But I have a bunch ready. I think we have 10 problems out of the review that we're going to do. And the first one is number 9. So, if you have any questions on 1 through 8, okay, just to kind of pull it up so you can see it. Okay. Oof, I got a lot of tabs open. Let me close all of these other ones. All right, so 1 through 8 on the review, we're really just converting and then doing some solving, right? So we're going to start off with number 9 and number 10, which are where you have to use the one-to-one. Okay, so the first few are just starting off with a log, converting it into an exponential, and then solving from there. So these ones will be a little bit different, number 9 and number 10. Okay, so let's start off with number 9. Okay, here it is. Okay, so these problems are just solve for x. Okay, so whenever you see these exponentials with bases on the left and the right, right, our job is going to be to try, and we're not always going to be successful, try to get the bases to be the same thing, right? So let me make sure my pen's working. There we go. All right. So for this one right here, I'm looking at the base of 4 and the base of 64, and I'm trying to think of a base that they can both be converted into, right? So 64 is actually 4 times 4 times 4, right? 4 to the third power. So I'm going to convert the 64 into 4 to the third, okay? And then next to the new exponent of 3, I'm going to put parentheses so I can put the current exponent of 2x minus 5, right? I'm not going to change the right-hand side because I made a base of 4 on the left, which means it now matches the base that's on the right. So I'm going to leave that one alone. Okay, so it's going to look like that. Okay. So now that I have a base on the left and a base on the right, and they are the same base, okay, I can just set the exponents equal to each other. So the real problem here now is to say that 3 times 2x minus 5 is equal to 3x. Okay, and now I just have to solve this. So I'm going to start off by doing a distribute. Right, that's 6x minus 15. Okay, and then I'm going to subtract the 3x to the left. Okay, and I'm going to add the 15 over to the right. Okay, and I'm going to divide both sides by 3, and I'm going to get that x is equal to 5. Okay, the domain for exponentials is everything. You can have positives, negatives, zeros, and okay exponents. So we don't have to check for extraneous solutions. X equals 5 is a good answer. Okay, so this is number 9. Problem number 10 is very similar. Here's problem number 10. Okay, it's still this whole kind of like exponentials, right? But we have two things that we have to do. One is we do have to get all the bases to be the same, just like the previous one. But then these two bases that are on the left, we have to combine so that there's only one base on the left and one base on the right. Okay, so I'm going to look at these three numbers, 9, 27, and 81, and realize that 9 is 3 squared, 27 is 3 to the third, 81 is 3 to the fourth. I can make these all base 3, so I'm going to start off with that. Okay, and as I'm going, I'm going to move kind of a little quickly because we have so many to do. If you have any questions about what I just did, just post it into chat, and I'll go back and answer those questions. Okay, so 9 I'm going to write as 3 squared. 27 I'm going to write as 3 to the third. Okay, and 81 I'm going to write as 3 to the fourth. Okay, and then I'm going to remember that if there's already a variable there, that I'm going to attach it. So this one's just going to be 2 times x. This one is going to be 3 times x minus 1. Okay, and then 4 didn't have 1, so I'll leave that one alone. Okay, so now my problem looks like this. Okay, so now we have two things that we have to do. The first one is going to be to combine these. Okay, so I'm going to distribute this one. All right, we'll just do it right here. I'm going to say instead of writing 3 times x minus 1, I'm going to distribute the 3 in and make this 3x minus 3. Okay, because now the rule says, and I'll just come over here and remind you, if I have something like x squared times x to the third, right? If I want to multiply something together that has exponents, as long as the bases are the same, I'm going to add the exponents. This would be x to the fifth, right? 2 plus 3. So I'm going to do the same thing here. I'm going to say this exponent of 2x, I'm going to add to this exponent of 3x minus 3, and that's going to make 5x minus 3. Right? 2x plus 3x makes a 5x. Okay. So I had to combine those because this property that we're using is called one-to-one. and that means that I have to have one base on the left and one base on the right, and they have to be the same. Okay, so now I'm in that situation, and that means I can set the exponents equal and say that 5x minus 3 is equal to 4. Okay, add the 3 over to be with the 4, so that'll be 5x equals 7, and then I'm going to divide, and I'll get this fraction 7/5. Okay, that's a 5 on the bottom. Okay, 7/5. Okay, so this is kind of the first topic, which is solving, right? And this is the one-to-one function, right? So we had, remember, uh, x equals 5, okay? And then this one, x equals 7/5, okay? So if there's any questions about those two, again, post those into chat. I'm monitoring it as I'm going, so let me know if you have any questions about those, okay? The next one that was requested was problem number 13, okay? Okay, so problem number 13, I just want to double check my instructions. Also solving, right? So all of these up through number 16 are solving, okay? So our job now is to solve this one. Okay, so I'm going to go back and remind you about a quick property of logs, right? So here's the kind of what a log is, what a logarithm is. If I had something like log base 2 of 8, okay, I'm asking you the question, what did you raise to a base of 2? What exponent did you use to get an 8? And obviously we know that 2 to the third is 8, so the answer to this would be 3, okay? And that means that I can take this equation, this log equation, and I can convert it into an exponential by saying if 2 is the base, 3 is the exponent, and then 8 is the output for that expression, right? So I can convert a log into an exponential just by kind of reordering those numbers, okay? And so I'm going to do that here, okay? But there's something weird about this one, and that is that there is no base, okay? So typically it would say like log base 2. This one doesn't have anything there, okay? So this is probably an obscure fact that didn't get hit on at length. Anytime log does not have a base, we always assume it's base 10, okay? And that's because our whole number system, right, is based on number 10, right? We have a base 10 system, okay? So this is really a base of 10, and now I can say, now if 10 is the base, okay, 3 is the exponent, okay? And on the other side, I'm going to have the answer, which is 5x minus 500, okay? And just as a kind of a side note here, because we're going to see it in a minute, right? You can see that in problem 14, there's numbers floating around on the outside of the log. Right? We got to get rid of all that stuff first. This one doesn't have that issue. There's nothing outside of the log expression. So that's why I was able to go right to converting, okay? So if I solve this one, 10 times 10 times 10 would be 1,000, okay? And now I can just finish solving this one. I'm going to add the 500 over. That's 1,500, okay? And then if I divide by 5 on both sides, I get that x is equal to 300, okay? So now, we do have to be careful with log problems. Log problems can have extraneous solutions, okay? And let me explain why this is true, because we might come across one of these a little bit later, okay? So I'm going to give myself a little space, okay? If I asked you the question, the log, we'll use a different base, log base 3 of negative 27, right? If this was my problem, okay, this problem does not have an answer, okay? And the reason that it doesn't have an answer is because if my base is 3, okay, and the exponent on the other side is telling me how many times I'm going to multiply 3 together, right, I'm never going to get an answer that's negative, right? 3 times 3 times 3 times 3 is always positive times positive times positive times positive. I'm never going to get a negative answer back, okay? So whenever we're solving log problems, we need to make sure that our answer, when I plug it back into the log, does not come out to be negative, okay? If it comes out to be negative, we're just going to kind of cross off that answer and we're done, okay? This one is fine. If I plug in 300, this is going to say 5 times 300, which is 1,500. 1,500 minus 500 is 1,000, right? And that makes a whole lot of sense because 10 to the third power is 1,000. So that's right? We know this answer is correct, okay? But we do have to just do a quick mental check, go up here and make sure when I plug it in, I don't get a negative inside of the log. Otherwise, it's not actually an answer, okay? So that's our first log problem. Everything else after this is just going to be a variation on what we just did. Okay, so the second problem here is same thing, right? It's a log. We're going to try to get the log alone. Once we get the log alone, we're going to just convert it into an exponential and solve. Okay, so in this case, this 3's got to go. So I'm going to divide by 3, and on the other side, divide by 3. Okay, so this is now log base 9 of 9x squared. and that equals 2. Okay? Now that my log's by itself, I can do a conversion, right, and say base of 9, exponent of 2, okay? And on the other side, I'm going to have 9x squared. Okay? So this is really 81, okay, equals 9x squared. Okay? I'm going to divide both sides by 9 to get rid of this 9 to get x squared by itself. Okay? So 81 divided by 9 is 9. Okay? And now I'm going to square root. Okay? And hopefully you have not forgotten, I know it's been a while, okay, that whenever I square root a squared, okay, we're going to get a plus or minus. This is actually 9. Square root of 9 is plus or minus 3. Okay? I'm going to go check my answers. If I plug in a positive 3 here, I get 3 squared, which is 9. 9 times 9 is 81. That's positive. That's good. I'm going to keep it. Okay? Don't throw away the negative, because if I do negative 3 squared, I'm going to get negative 3 times negative 3, which is positive 9 times 9, which is positive 81. Okay? So I actually have to keep both of these answers. If you forgot about the negative 3, you're actually missing a solution. Okay? So be careful when you whenever squared show up, you do have to do plus or minus. Okay? So problem number 14. Okay? And again, if you have any questions as we're going, feel free to post those. Okay? This one looks pretty straightforward, right? This one's the same thing. I have that 5 on the outside, right? Problem 15. Okay. Excuse me. So I'm going to divide that away. Okay. On the other side, I'm going to divide. Okay. And I'm going to say that now makes the log base 2 of 13x minus 1 equal to 6. Okay. And now I'm going to do my conversion. There's nothing outside of the log, so I'm going to say 2 to the 6th power is equal to 13x minus 1. Okay. 2 to the 6th power, I believe, is 64, if I'm remembering correctly, because 2 to the 5th, yes, so 64, okay, and 13x minus 1, okay. Add the 1 over, and that's going to be 65, okay, and then x is equal to, I believe this does not work out nicely, because if we do times 5, oh, no, times 5, that works, so this is a 5, okay, and that would be my answer. Okay, so let's just do our quick mental check. 5 times 13 is some really big number. When I subtract 1, it's still positive, right? So I don't have to really even care what that number is. This one's good, okay? Not extraneous, okay? So that's problem 15, okay? Here's problem 16, okay? So a little bit more going on here. Here's a couple weird things about this one. First one is now the base is the variable. Instead of it being like inside of this expression in the parentheses, it's now the base. Okay. The other thing is now instead of it being 12 log, right, 12 times log, it's 12 plus log. So I'm going to start off by getting rid of the 12 by subtraction, right? This is not a same thing as if you want to see the difference. This one, the 5 was just attached to the log. It's multiplying. This one is being added, so we're going to get rid of that by subtracting. We're going to do minus 12, okay, and minus 12, okay. So that's going to say log base x of 125, okay, is equal to 3. Okay, so now I have to solve this one. This is x, base of x, exponent of 3, so that's x to the third is equal to 125. Okay, couple ways that you can solve this. Okay, first one is that you can just cube root. So if I want to, I can get rid of a cube by using the cube root. Okay, we saw that in the radicals chapter. And that would make x equal to, well, 5 times 5 times 5 makes 125, so this is going to be 5. Okay. The other thing you could do, okay, is we can use the one-to-one function a little differently. Right, so I'll kind of show you the alternate way. And this is just, depending on how your brain works. Okay, I can rewrite 125 as 5 to the third. Okay. And the one-to-one property says if the exponents are the same, that means that the bases have to be the same. And so I can just say, well, that means that x has to be 5. Okay. So whichever way you decide to solve this one, okay, gets you the same answer. X is equal to 5. Okay. No problem with the base being negative, right? So I don't have to worry about checking this one. It's just this number on the inside that has to be positive. Or, positive. It can't even be 0. Okay. So again, if there's any questions about log, I think we're done with logs. Yep, we're going to graph in a sec. Okay, so we have a couple of exponentials, okay, and then we have 3 log problems, okay, all of which had solutions, 4 log problems, okay. So now we're going to graph. Okay, this was what we did all the way at the very beginning, so this one might be a little bit shaky compared to everything else, okay. And the request for this was only for number 17, 18, 19, and 20 all ask questions about this graph, so if you want to go over 18, 19, or 20 after we graph this, just let me know, okay. All right, so graphing an exponential. So all we're going to do here is we're going to set up our XY chart. Okay. And we're going to pick numbers. We can pick anything we want to pick, okay? Our goal, though, is to try to get something that looks like flat and then shooting up really fast. And if you watch the news at all, you've probably seen this graph a lot, right, with everything that's going on, okay? So we're going to look to try to get enough points that we can sketch it and see the flat part of this graph and see it start shooting up, okay? So I'm going to plug in some numbers. I'm going to start off with our kind of standard few, which are -2, -1, 0, 1, and 2. And we're going to see how this works out, okay? Some of these numbers might be too big or not really fit on our graph, so we'll see as we go through, okay? So let me get rid of this. All right, so we're going to start off with plugging in negative. Well, let's plug in the easy ones. If I plug in a 0, here's what you got to remember about this, and this is true of all of these problems. This -2 that's sitting out here has to wait until we do 2 to the whatever power. Then we'll go back and multiply by the -2 because PEMDAS says exponent, then multiply. Don't do -2 times 2, get an answer, and then raise it to the power, right? We can't do that. So if you're having any issues with this one because of that, be careful. That's very common, okay? So I'm going to start off with 2 to the 0 power, okay? 2 to the 0 power is 1, right? So this is going to be -2 times 1, which is -2 plus 4. So that looks like a 2, okay? So when I plug in 0, we get back 2. Okay? We'll do the rest of these a little faster. Okay? If I plugged in a 1, okay, this is going to be 2 to the first power, which is 2. Okay? This will be -2 times 2, which is -4, and -4 plus 4 is 0. Okay? And then this next one is going to be 2, excuse me, 2 as the exponent, so that's 2 squared, which is 4. Okay, 4 times -2 is -8. -8 plus 4 is -4. Okay, so those are 3 of them. Let's get these on the graph, okay? And then we're going to think about some things before we continue. So 0 goes up to 2. That's right here. Okay. 1, 0, which is right here. And 2, 1, 2, down to -4, which is right here, okay? So you might have graphed some of these and said, hold on a second, that does not look like this thing, right? So here's what we have to think about. Hey, transformations, our good friend BCAD, right? If you remember BCAD, okay? Transformations are going to apply here. So when we think about our graph, we don't have to like list them or do anything with them, but we at least want to think about what these numbers, right, the -2 and the +4 are going to do to this standard parent function graph, okay? 2 things are going to happen. The +4 is going to slide our graph up, right? So instead of it being like, if this was our kind of like typical graph right here, right, where it's going to slide it up some, so it'll kind of be up here a little bit, okay? The other thing that's going to happen is that this -2 is going to flip the graph over, right? So let's kind of like, I'm going to do like a rough sketch here. It's going to move up to -4, right? Our asymptote, which is usually at the axis, is going to slide up to 4. And instead of it being above the line like this, the -2 is going to cause it to be below the line, okay? And so if you take a look at our points, that this right here is actually this, right? So it does make sense, our points, right? It's just going to be that the asymptote, which that's one of the questions they asked, is going to be up here at 1, 2, 3, 4. Instead of it being y equals 0, which is the x-axis, it's going to be up here. So I'm going to just draw that in, okay? So what we're expecting when we plug in these negative numbers is that this is going to start kind of like turning. And as it gets close to this asymptote line, it's going to flatten out. And it's not going to go through it, right? It's going to kind of get close to that line, ride right along it, and get as close as we can, but never actually touch that line, okay? So let's put in these other 2 points, okay? And we'll see where we're at, okay? So the first one says -1, okay? So if I plug in a -1, again, we'll be careful with this one because it's got a negative, okay? So 2 to the -1, if you just type that in your calculator, you're welcome to do that because we're graphing, is 1/2, right? It's 0.5, okay? So if I do a half, okay, times -2, and then add 4, well, -2 times a half is -1 plus 4, and that looks like 3, okay? So let's see how that looks on our graph. -1 goes up 1, 2, 3. So that looks good, right? It's starting to kind of turn a little bit, right? And if I plug in a -2, this is going to be 1/4, okay, which is 0.25. Okay, if I do negative 2 times 0.25, I get a half, or negative a half. Okay, and negative a half plus 4 is positive 3.5. So that's going to be at negative 2 input, I'm going to get positive 3.5. Okay, so if I go from negative 2 up to 3.5, you can see it's flattening out a little bit. Okay, if we did more points, you'd see that it just kind of keeps going like this. So I'm just going to sketch this. We know that it's going to ride right along this line. Okay, and then it's going to start turning. Okay. It's really difficult to do this with a writing slate. Okay, and we're going to get down here, and it's going to look something like that. Okay, so this is going to be our sketch. Okay, and then here's your quick answers to the rest of those questions. Right, the first question is, what is the range of this function? So number 18 is, what is the range? You can see that this thing goes down forever, so it's going to go to negative infinity. Right, so let's just kind of write it down here. Here's the range. Okay, it's going to go to from negative infinity up as much as we want. It's going to hit 4, or not hit 4, get close to 4, but never actually hit 4. So this is going to go up to 4. Okay, and I'm going to put a parenthesis, not a bracket, not a square bracket, because it's never going to touch 4. Okay, another way of writing this is you could also write this as y is less than 4. Okay, so it'll go down forever. Okay, so that's the first question. Problem 19, what is the equation of the asymptote? The asymptote is this line, which is y equals 4. Okay, we always just describe horizontal lines as y equals wherever it hits the y-axis. Okay, and the number 20 says, what is the y-intercept? Y-intercepts are what happens when you plug a 0 in for x. So we'll say this one right here, 0, 2. Right, that's going to be, and you can see it on the graph right there. Right, that's going to be our y-intercept. Okay, so that is problem 17, 18, 19, 20. Okay, and then the next question was about 22. What was 21? I'm curious. Oh, 21 was our first compounding interest one, so it'll be kind of very similar to this one. Okay, so here's what's going on with this one. Okay, this is talking about being compounded. Okay, and if you're just joining us, I know some people just popped in. If you're just joining us, if I skipped over anything that you wanted to go over, please let me know, and I can go back and add those ones. These are just the ones that were put into the comments. Okay, all right, so back to 22. Here's what's going on. This problem says, how much money do you need to invest in an account that is compounded daily, okay, at a rate of 3% in order to have $5,000 in 6 years? Okay, so I'm going to start off by writing down the formula that you're going to need. Actually, instead of me trying to write it because it's going to be terrible, let me just Google it real quick. Compound interest formula. Okay, I'll bring up a nice one. Okay. Oh, there it is. See if I can copy and paste. Nope, that didn't work. Let's try one more time. I'll just snip it. That'll work. Okay. So we'll use our snipping tool. And it looks something like this. There we go. All right, that worked. Okay, so this is our compound interest formula. Just to remind you about what these things mean. Okay, A is going to be like kind of the output. That's going to be how much money you have after your interest has sat there for a while. What's going to be in your account, right? So A for account. P is stands for principal. Principal is your starting value. Okay. R is the rate. It's the annual rate. Okay. So you can see that this one does say 3%. Okay. So we'll turn that to a decimal. N, which shows up twice in the formula, that's going to be the number of times that you compounded. Okay, so this word compounded daily is going to show up. And then T is the amount of time in years, right? For compound interest, it's always done in years, okay? So if I plug what I know from this problem into my equation, here's what I know, okay? I know that the rate we just said was 3%, so that's going to be 0.03, okay? The N value is always, always going to be determined by what comes after the word compounded. Compounded daily means 365 times in a year. So I'm going to make N 365, okay? Which means it's also going to be 365 in the exponent. And then 6 years is my T, okay? What I don't know is P, okay? So I'm going to put P here, okay? And the reason I don't know that is because, remember, this is the starting value. And they're asking me the question, how much money do you need to invest? So we're kind of saying, like, I don't know what my starting value is, but what I do know is after I invest that money for this amount of time, okay, at this rate, I would like my output to be 5,000. Okay, so I know that's 5,000. Okay, really quick, I want to check and see. I just had an email come through. I want to make sure I'm not adding questions. Okay, all right, so this is my setup. Okay, so I'm going to simplify some stuff. Okay, I want to get p by itself. That's going to be the answer to the question. Okay, but what I do want to do is pull up my calculator real quick. Okay, and I'm going to simplify this whole thing. Okay, so I'm going to type this in. So let's start off with 365 times 6. Okay, I can simplify that. 2190. Okay, so I'm just going to kind of write some of this down. So our exponent is really 2190. Okay, and then I'm going to do this 0.03 times 365, add 1 to it, right? So remember, again, do things in order by PEMDAS. So 0.03 divided by 365 is going to be a really small number, okay? It's so small that it's giving it to me in scientific notation. It's like 0.00008. Very tiny, okay? I'm going to add 1 to that, okay? Maybe plus 1, okay? So now it's that number. Right, and you can say 1.00008, right? This, okay, is the base. 2190 is my exponent, so I'm going to do x to the y, and I'm going to type in 2190, okay, and hit enter, okay? So I get this really long number. Obviously, you don't need 20 digits, so I'm just going to write down some of them. Let me pull this over to my other screen so I can write and see it at the same time, okay? All right, so I'm going to write this down now. Okay, this whole thing, after I simplified this, raised it to the 2190, that's going to be 1.19. I'm going to keep like 4 decimal places. 72. Okay? All right, that's what that came out to be, and it's times p equals 5,000. Okay? So whenever something's being multiplied by a variable, just get rid of it by dividing. So I'm going to divide this by 1.1972, which means I got to do the same thing on the other side. 1.1972. Okay? Let's bring my calculator back. Okay, so now I'm going to do 5,000 divided by 1.1972. Oop, let's try that again. Oh, here it is. All right, so this number right here, 4176. Okay, that's my answer. P, I'll just do it over here. P equals, what did I say it was? 4176. Okay, so you need to invest 4176, about $4,176. Okay, and as the 6 years goes on, you'll slowly get interest, and at the end of the 6 years, you'll end up with $5,000. Okay, so that's kind of a variation on 21. 21, they gave you the starting number, right, and asked you to find the ending number. This one's just the opposite. Okay, so we're gonna revisit a problem like this a little later once we start doing some more log solving, where maybe we know p, but we don't know like the time or the n value or something like that. Okay, so we'll revisit this at a later date. Okay, so again, if there's any questions, this is compound interest. Okay, number 22. Okay, 23. Okay, is about my Sims community. Okay, so here's what this one's saying: the population of my Sims community is growing at a rate of 3.25% every 7 years. Okay, that's going to be important. If there are currently 10,000 Sims, how many people will be in my virtual city in 70 years? Okay, so we got to think about this one. All right, so here's the first thing. First thing is, I see no mention here of compounding. Okay, the previous problem specifically said compounded daily. Okay, there's no mention in this new problem about the word compounding. If it doesn't say compounded, here's what your problem's going to look like. When we're talking about growth, percentage growth like 3.25, we're just going to say A times 1 plus R to the T. Okay, and that's going to be equal to our output. Okay, which I'll just call, I don't know, what do we want to call that? Let's call it like population, so I'll call it P. Okay, so this is going to be my standard formula. This is not compounding. It's just like regular problems. Okay, so I'm going to plug this information in. Here's what I know. I started off at 10,000. Okay, and I'm going to do 1 plus my rate, but as a decimal, so 0.0325, okay, to the T. Now, here's where we have to be careful. T in compounding is always done in years. Okay, so I had to plug in a 6 because it was 6 years. Okay, this one, T represents how many times did the increase happen. Okay, so it's a little bit more general. Excuse me. Okay, so when they say that this change is happening, this 3.25% is happening every 7 years, okay, I'm going to say on year 7, 14, 21, 28, and I'm going to keep going until I get to 70, right? So it's only happening 10 times, okay? So you do have to be careful when you're doing these. If that percentage change is not happening every year, if it said 3.25% every year, then T would be 70. But because it's happening every 7 years, T is only going to be 10, okay? So you just got to be careful with some of these, the wording of some of these problems, okay? So now it's just calculator problem. So just be careful with your calculator again, okay? So I'm going to start off by doing 1 plus, oh, not 0.1 plus, okay? 1 plus 0.0325, get that answer, okay? And then I'm going to do x to the y, so I can raise it to the 10th power, and I get that ugly number, okay? And then I'm just going to multiply it by 10, or by 1,000, okay? No, 10,000, I'm sorry, because that's my population, okay? And I get this number 13,769, right? 13,769, okay? And this is supposed to be 10,000, okay? P equals, okay? So that would be the answer to this question. The big thing I think to watch out for is, one, make sure you're using the correct formula, and make sure that your exponent reflects how many times we increased, not how many years have passed, okay? So that's 23. And this is the last one that I've been requested to do. So I'll go back over the problems that we've done if you joined us late. So you can go back and watch the video on those ones. Okay. Otherwise, I can go over anything else. Okay. So last problem says, given the function j of x is equal to 5,000 times 1.625 to the x, identify the percent increase. Okay. So I'm going to go back to the previous problem. The previous problem said our rate of increase, okay, because I was growing, okay, so that's an increase at a rate of 3.25%, okay? In that case, okay, this number right here, okay, the R value, okay, that is the rate of increase, okay? So when I see a problem that looks like this, what is the rate of increase, the percent increase? It's going to be the decimal, right? So you'd see that we added 1 to get 1.0325. Well, in this problem, it's 1.625. So if I were to rewrite this one, okay, I would say this is really 5,000 times 1 plus 0.625 to the x, okay? And that would mean that 0.625 is my rate, okay? If I move the decimal over twice, or if I just multiply by 100, right, that would be 62.5%, okay? So we basically subtracted the 1 off to get it to be just the R part of the problem, okay? And then we did 62.5%, okay? So that one's pretty straightforward as long as you kind of draw the connection between this number, okay, and the formula with the 1 plus R. Okay, so here are the problems that we went over. So again, if you joined us a little late, okay, you can go back and just watch the video of this and fast forward to whatever problem you want to work on. Okay, we started off at number 9. Okay, so we did 9 and 10. Okay, we skipped over 11 and 12. Nobody asked me to do those. Okay, so if you want me to do those, let me know. Okay, 13, 14, 15, and 16. We're all done. Okay, 17, we did the graph. And I answered the questions about 18, 19, and 20. So they're not, here's the range problem. The other ones I just kind of talked about. So if you go back and watch the video, you'll get answers also to 18, 19, and 20. Okay, and then we skipped 21. Nobody asked about that one. And we did 22, 23, and 24. Okay, so that was a lot of the review already. So if you have any additional questions that you want to go over, I'm going to hang out for maybe another 10 minutes or so just to see if anybody posts anything. Otherwise, have a good weekend, and I will talk to you guys again on Wednesday. Okay. All right, so here's number 6. Okay, so this is a solving problem as well. So for a problem like this, you're going to, if you look back at some of the other ones that we did, let me go back. Okay, so problems like this, oh, not that, like this. Okay, so for problems like this, what we ended up doing was we said if the base is something like 10, as long as the log is by itself, which in this case it was, we could just convert it into exponential. So base of 10, exponent of 3, this number goes on the other side. Okay, so for the problem number 6, okay, let me go back to that one. Okay, you can see that there's nothing outside of the log, right? So this one is ready to be converted. So we're going to say this is base of x, exponent of 4, okay? And I have a 128 on the other side, okay? So the way that you're going to simplify this one and finish it is to, got a couple of options. One is to fourth root, okay? So I can do fourth roots to get rid of powers of 4. I don't know if my calculator does fourth roots. I don't think it does. Okay. No, it doesn't. Okay. Maybe it does. Oh, there it is. It does. Okay, so I'm going to do 128, and then I'm going to hit this button with a root of 4. Let's see if that works. I don't know if that worked. Okay, it didn't work. Let me just pull up on my calculator. Okay, so you got to find your fourth root button. Okay, fourth root of 128. Oh, no, it was right. The fourth root of 128 is about 3.36. Okay, so it's not a nice number. So this one's going to be 3.36. Okay, so that's going to be the easiest way to solve this one. 128 does not convert nicely to a fourth power, so I can't use the, bases are the same, exponents are the same, right? You just have to use your fourth root button. Okay, so we learned about some of these when we were doing radicals. Okay, so that's problem number 6. Okay, so again, I'm here for a few more minutes. If you guys have any questions about anything else, again, we went over a lot of them already, but 1 through 5, and I think like 21 and one more. So if you have any other questions, please let me know. I'm going to be here until there are no more.